What's happening, you guys, and happy Monday. Welcome back to the Orlando Science Center. This month at OSC, we're highlighting Physics Month, and what better to learn a lesson about physics in regards to paints and pendulum swings, right?
Yes, exactly. We're going to do a little bit of some messy science. This is an experiment that we're going to do during Mess Fest. This is May 9th and 10th here at the Orlando Science Center. This is our paint pendulum. Normally we would have a bunch of different paintings on the ground and make a large tapestry. Today we're going to do some plexiglass painting, learning a little bit about the physics. We're going to go ahead and start our activity in 3, 2, 1. So our pendulum, as it swings, is going to start forming this geometric pattern. This pattern that you see here on our canvas and on our plexiglass is known as a Lissajous curve. Lissajous curve is measuring the swing of this pendulum on a 2D plane. You can see right there as it's starting to form. However, we are losing mass. We are losing paint, and as we lose that paint, we are actually descending. You can see this curve is shrinking inwards. The reason it's shrinking inwards is because of that loss of mass. It is losing inertia and momentum. It's also due to the friction as this pendulum is swinging through the air. It is pushing against those molecules, and those molecules are pushing back against it. So we're going to get this descending Lissajous curve. This is perfect geometry and physics in motion, and it creates a pretty cool product along the way. So we're going to see it fill out our paint pendulum on the plexiglass, and we're going to be able to let this dry and have a cool, clear 3D painting.
Yeah, who knew math could be so beautiful, right?
Exactly, right? So it's a perfect way to get geometry involved in art. You see artists do this all the time on the internet, and you can see that the oval of the pendulum is actually rotating around this center axis. That's because this is a 1-to-1 pendulum. The full length of the pendulum is the same length on the x-axis as it is the y-axis. Let's say at the halfway point of this pendulum, I had it split in 2. That means one axis would actually be longer than the other, and it would actually create a fully different pattern. But this is your most simple descending Lissajous curve. You can also see a point where it's actually getting a lot tighter, where the bounds, the rings essentially are getting a lot closer. That is the Lagrange point of this Lissajous curve. This is the point where those ovals, x and y axis, are rotating around. That's the focal point of this painting.
It's cool to notice that not only is the bottle of paint itself revolving around an axis, it's actually also spinning on itself too.
Yeah, exactly. This is because our rope here is a typical spun rope, and so it's going to have some twist to it as well. And you're going to be able to get all of this awesome physics at Mess Fest here at the Orlando Science Center all month long.
Sweet. Well, all throughout the month of May, we're highlighting Physics Month, and I can't wait to see all of you guys' faces right here.